Welcome to Global Site Engineering, where we bring construction and plant engineering knowledge to life. Today we'll learn about Valve Material Specification, what it is, how to choose the right materials, and why it's critical for safety and performance in oil, gas, and process plants. Valve Overview, Basic Parts. Let's begin by understanding the main parts of a valve. Every valve has a body, a bonnet, trim components like disc, seat, stem, and seals, or gaskets. Each of these parts has different roles and requires different material properties. What is Valve Material Specification? A valve material specification defines the materials used for all valve parts. Material selection depends on three major things: type of service fluid, oil, gas, water, steam, or chemicals, operating pressure and temperature, corrosion and erosion risks, like hydrogen sulfide, carbon dioxide, or chlorides. Standards followed include ASTM, API, ASME, and NAC. Valve body and bonnet. Now let's go deeper, starting with the valve, body, and bonnet. These are the pressure-containing parts. They must withstand internal pressure, operating temperature, and corrosion. Common materials are carbon steel, ASTM A216 grade WCB for general oil and gas service, stainless steel, ASTM A351 grade CF8M for corrosive fluids, duplex stainless or Inconel, used in sour service or where chloride content is high. Valve trim, disc, seat, stem, plug. Trim parts include the disc, seat, stem, and plug. These are in direct contact with the fluid and require high strength and corrosion resistance. Common materials: 13CR or 17.4 pH for moderate corrosion, stellite, a cobalt alloy used for wear resistance on seating surfaces, monol, hastelloy, Inconel for sour service and highly corrosive environments, seals and gaskets. Next are seals and gaskets, which must be compatible with both fluid and temperature. Their failure can cause leakage or accidents. Materials used include PTFE, Teflon, for chemical resistance, Viton, for high-temperature oils, graphite, for high-temperature steam, NBR, Gisech, or EPDM, depending on the chemicals involved. Let's look at the complete material list of this industrial valve. Each component is carefully selected to ensure durability, resistance to corrosion, and performance under pressure. Material list table. Part name material. Bonnet DI, terms WCB, CF8, CF8M. Double end stud, A193B8. Nut, A194B8. Body gasket, PTFE, ball, SS304. Shear SS3-16. CTFM 6600, body DI, WCB, CF8, CF8M, anti-static device, stainless steels, steam SS3Z4, SS316s, thrust washer, RTFE, O-ring Viton, packing TFM 600, packing gland stainless steel CTS, disc spring stainless steel SES, packing gland WCB, Azure SS, screw A193B8, nut, A Here's an example of a real-world valve material specification used in piping. Part material specification application. Body ASTM A216 grade. WCB general oil and gas service. Bonnet ASTM A351 grade, CF8M corrosive fluids. Seat, stellite hard-faced wear, resistance. Stem ASTM A276 type 316 corrosion resistance. Ball, churns or disc, ASTM A182 F316 corrosive service. Gasket spiral wound, SS plus graphite high temperature sealing. Now let's look at some special conditions that need specific materials. Sour service. Use materials as per NACMR 0175, ISO 15156. Prevents sulfide stress cracking. Higauber requires low hardness and special metallurgy. High temperature service. Use heat-resistant alloys. Graphite gaskets. Avoid soft elastomers, cryogenic service. Use 304L or 316L international standards. All these material choices are governed by international standards such as API 6D, pipeline valves, API 600, API 602, API 63, API 608, API 609, for gate, globe, ball, butterfly valves, ASME B1634, pressure temperature ratings, ASTM, material grades and testing, NACE MART 01175 for sour service. To summarize, valve material selection is not just about cost, it's about safety and performance. Poor selection can lead to leakage, corrosion, or even explosions in oil and gas systems. Always follow correct specifications based on standards and process conditions. Thanks for watching. If this video helped you, please like, share, and subscribe to Global Site Engineering. More practical engineering content coming soon.